Hello everyone, this video is going to be about transforming linear functions. I've taught you all about how to graph linear functions and how to plug in numbers into linear functions. And what we're going to do is we're going to see what changes whenever you change the parent function. That's what it means by transformation. That just means something is going to change. We're going to interpret the meanings. So we're going to make predictions of what a transformation to the equation would actually do in real life. Please write this definition down in your journal. A transformation is defined as a movement of a geometric figure. So I just said it was a change because of this next sentence. Since the graph of a linear function is a line, the transformation of the function is a movement of the line. So whenever you move the geometric figure, which just means the shape or whatever's going on a graph, some sort of picture, when you move a picture, you're actually going to be changing the equation that goes along with that picture. And the equation that we use most commonly with graphing is slope-intercept form. You should be able to fill in these blanks pretty easily. The slope-intercept form of a linear equation is y equals mx plus b, where something is the slope. You better know that m is the slope, and then down here, m is the slope, and something is the y-intercept. That something is the letter b. Make sure you're finding a way to fill in these notes. Even if it's review, writing it down again is still helpful. In this graphing little picture, we're going to put y equals mx plus b, not mx plus x, mx plus b. And what they're doing with this little coordinate here is they're saying whenever you plug in 0 for x, you should get b for your output, which is y. Let's do our first example together. We have a health club, and you have to pay a one-time fee. One-time fee. That means you start and you're going to pay this. This is a starting cost. And that is always going to be the y-intercept, plus a monthly charge. This is happening repeatedly, so that's going to be m. It says that prices have increased, so that means something's going to be changing in this equation. It was one thing, now it's going to be changing. The old equation is that f of x equals 25x plus 100. If you're copying this into your journal, you would write this original equation, and we're going to graph it. They gave you, if you look at this graph to the right, it says g of x. Now where in the story is g of x? G of x is right here, and g of x is talking about the new one. So the old one is f of x. And we're going to say, how does it change to become g of x? Well, they didn't give you the equation for g of x, so after you graph f of x, well, let's work on this graph. Here's the number 300. So let's see what we're counting by. It looks like every 2 will be 100. F of x starts at $100, and then it goes up by $25 every month. That's going to charge $25 every month, which means it's going to take 4 months to go up $100. It's going to take 4 to go up 100. But that's not actually the line, that's just the rise and the run. So 4 and 200 is the next spot. Connect those two with a line, a very straight line. And based off of this graph, we can tell that it doesn't look like the slope changed for g of x. The black line and the red line, they look like they have the same slope and that they're parallel. The only way to know that 100% for sure, though, is to actually find the slope using the 2 points that they gave you. But what we can see right away is that g of x is using 0 to 50. And according to this up here, where the line touches the y-axis is going to be, it's going to give us the letter b. So this 250 is in the place of b. So g of x the new g of x is equal to something times x plus 250. To make sure that the slope did not change, or to see if it did change, we need to use this point and that point. So we'll do y2 minus y1 over x2 minus x1 to see 550 minus 250 over 12 minus 0. The bottom doesn't change. The top, the 50s will balance out, and we'll be left with 300 over 12. 12 fits in a 30. 2 times 6 with the 0 remaining. 60 remaining, so it'll be 25. M is 25. All right, so now we're going to say, how did f of x become g of x? What changed? We added 150 to the y-intercept. Let's see if the next question goes a little bit deeper into that. Write the equation for both lines in slope-intercept form. How are the values of m and b related? How are the values of m and b affected by transforming f of x to g of x? Interpret the meaning of the slope and the y-intercept in the context of the problem. Okay, so we will go a little bit deeper. Pretty much we're going to copy what we have here, but instead of using the function notation, we're going to use slope-intercept form, which is y equals. So instead of putting f of x, we're going to write y equals, well, let me use the same colors that I was using before. Y equals 25x plus 100. And second one was y equals 25x plus 250. How are m and b transformed? How are they affected? M stayed the same. B went up by, well, it started at 100. It ended at 250, which is a plus 150. B went up by a positive 150. Now we're going to interpret that. 25 meant something. 25 meant something. And we labeled what it meant at the very start. M, the slope is representing a monthly charge, which means that the $25 monthly charge stayed the same. However, the y-intercept, and what does the y-intercept represent? The y-intercept is the starting cost. It's right there in red. However, the starting cost increased. And that's how we went from f of x to g of x, and that's how you would explain it to somebody else who only knows business and doesn't know math. Suppose the new membership cost could be shown by this one. That's h of x, which is an entirely new one. Graph and label f of x and h of x. Describe them. Okay, so the first thing we're going to do is we're going to graph this new one and the old guy. Well, luckily I have the old guy written right there in red. So 25x plus 100. So we're counting by the same. If you're making your own graph, you can have it count by the same spaces. Count by 100s for the y's and 2's. So our starting point was at $100, and 4 months later we increased by $100. It's the same logic that I used to graph it, the red one, the first time. Now let's graph the purple one. The difference is we're starting at the same $100. And instead of increasing by $25 a month, we're going to charge $50 a month. So that means 1 month later, I'll go up 50. 2 months later, I'll be $100 more. 3 months later, I'll be there and there. And let's connect these. This one is now h of x, and in the red, I have f of x. Remember, f of x and h of x, those are just names so that we know which one is which. But it's the same thing as y equals something. It just has a name now. At least at this point. Eventually you can do more with functions, but right now it's just the name. We graphed it, we labeled it. Now let's describe the transformation from f to h. What was the only thing that changed between these two lines? They had the same y-intercept, but something else was different about them. The purple line is increasing faster, and the rate of increase is called the rate of change. So the slope of h of x is higher. Then the second question, how does this transformation differ from f of x to g of x? And the other question, the y-intercept changed. But the slope didn't. And that's how these are different now. The starting point of transformations for linear functions is the parent function. I'm reading this middle paragraph. For graphing purposes, y is equal to f of x or y equals x. So this is just what I just said earlier, that f of x is the same thing as saying y equals. At least right now. Eventually, you can do more with functions than you can with y equals.